right, students, welcome to this video in which we are going to discuss elemental abundance in the universe, okay? As you might remember, the word abundance simply means how many or how much of something there are, okay? So if something has a high abundance, that means there's a lot of it. And so we're going to be discussing elements in the universe and how much or how many of each element we tend to see. Let's do a quick refresher on our elements. Here we have our trusty periodic table of elements. And as you might remember learning, elements are just simply the basic building blocks of which everything in nature is created, okay? Elements often don't exist just by themselves. They oftentimes combine, okay, into what we would call a compound or a molecule. But all matter starts with these basic elements. So we have hydrogen and helium, okay? And then there'll be some other ones that you recognize here. Oxygen in the air that we're breathing, as well as nitrogen, carbon in our bodies. We have copper and silver and gold as we get down into the metals, and so on and so forth, okay? So as we survey the universe, we are asking the question, how much of each of these elements are there? Is there more of one type than another? And as we will quickly see, the answer is yes. There is more of certain types of elements than others. But before we get to that, let's talk about how we could possibly even know. How might we even know how much of different elements there are in the universe? Okay, it's not like we can just send out a survey or a census and get that answer. So to do so, we need to first talk about a process that is called spectroscopy. Spectroscopy, okay? Spectroscopy is it's really an ingenious way that scientists and astronomers and physicists have been able to discover the types of elements that are out there in the universe. It all starts with a light source, a source of continuous light, or light that is producing the entire visible wavelength spectrum of light, okay? Such as a star, okay? The next step is as that light passes through matter in the universe, let's say this cloud of gas or a nebula, okay, is made of certain elements. Well, those elements, as you can imagine, some of those gas and dust particles will absorb some of that light. In other words, not all of the light passes through. It gets absorbed, okay? It gets absorbed. And so then if we are on the other side of that light, say standing here, and we are looking at the light that comes through, guess what we see? We see the same continuous spectrum that we started out with over here, except some of the light is missing because it was absorbed by the gas, the nebula, okay? And it turns out that the particular pattern that's created, it kind of looks like a barcode here. There's a missing line of light here, and a missing line of light here, and a missing line of light here, and so on, okay? The particular pattern actually indicates the type of element or matter that the gas is made of. It's amazing, okay? Every element has its own specific spectral lines. They're called spectral lines, okay? Now, to look at what about the second scenario, some of this gas is going to absorb and then emit some of that energy, okay? And it emits that energy, you guessed it, in the same pattern that it gets absorbed, except instead of seeing absorption lines here, we are seeing emission lines. Emission spectral lines, okay? And so through this process of spectroscopy, scientists, physicists are able to determine what is this gas made of, okay? It's through the spectroscopy. And as I said earlier, you can notice that every element, and here we have 4 listed, hydrogen, helium, sodium, and mercury, every element has its own unique pattern, okay, of spectral lines. These are spectral emission lines. kind of like its own unique fingerprint. And so if we see a pattern such as here with hydrogen, right, we can know that the gas is hydrogen, that it's that type of gas. And sometimes we might see a pattern that includes two or more sets of patterns, and we have to distinguish one from the other. But we can tell that maybe a nebula is made of hydrogen and helium because we see a combination of both of these spectral lines, okay? So really, it is using light and our knowledge of the electromagnetic spectrum that allows us to determine the composition of the different elements, the abundance of different elements in the universe. And so here we'll break down just like the top 8 or so, okay? It turns out that hydrogen, by far and away, is the most abundant element in the universe, okay? Both in terms of the actual number of atoms as well as the mass. Okay, here we are listing the mass of matter in the universe by element. 75% of all matter in the universe by mass is hydrogen. Helium makes up 73%, okay? Or excuse me, 23%. If you're doing the math in your head, I'm sure by now you can figure out 75 plus 23, that's 98%. 98% of all matter in the universe is hydrogen and helium, which leaves just a very small percentage of everything else. Oxygen 1%, carbon 0.5%, neon 0.1%, iron 0.1%, nitrogen 0.1%, and all other elements on our periodic table make up the remaining 0.2% of the matter in our universe, okay? So with that knowledge, let's go ahead and look at a couple practice problems. Question number 1. What technique do scientists use to measure and interpret light wavelengths from the electromagnetic spectrum? Well, we talked about it earlier. It's called spectroscopy, okay? Spectroscopy. Question number 2. An unknown gas is energized and emits 2 spectral lines at wavelengths of approximately 605 and 608 nanometers. There are no other spectral lines present. What element is being measured? Well, let's look on our little handy chart over here. 605 and 608 appear to be right about here on our chart, and we're looking for 2 lines. We go up. Looks like right here we've got sodium as a likely candidate for our spectral emission lines, okay? And we see that there are no other lines on the rest of the spectrum being emitted by this element, and so sodium is our most likely candidate as the element, the unknown element being measured here. Question number 3, why does the universe tend to favor hydrogen and helium above all other elements? In other words, why is there such a high abundance of hydrogen and helium in the universe? Remember, we talked about before, by mass, hydrogen and helium make up approximately 98% of all matter in the universe. Why is that? Why isn't there more gold, for example, or more silver, or more titanium, or more carbon? Well, we are going to answer that question in a coming video. So stay tuned, and we need to take just a bit more information to be able to piece together that question before we can answer it. But until then, take care, and hopefully this has been a useful review about how we determine the elemental abundance in the universe.